This video we're looking at performing the distributive property. So I can perform the distributive property and I can solve equations using the distributive property. Solve linear equations in one variable here is our standard. So what does a distributive property mean? There's a lot of different ways to think about it, but if you think about this problem, 4 times 24. It might be easier to think about it as this 24 being two different chunks of 20 plus 4, because 20 plus 4 is still 24. So if I think about it kind of like this, and I separate it out, it's like I'm taking this 4 times each piece that made up 24. So 4 times 20 gives me 80 plus 4 times 4 gives me 16, and when I add those together, I get 96. And so I can use the distributive property as a way to chunk this thing out, and I'm taking this number that I wanted to multiply times each chunk here, okay, and one at a time, and then I'm combining those terms together. So it also might be easier to think about it like this: 4 times 20 plus 4, and that 4 then is going to be multiplied times each piece, and so I think in elementary you might have learned this way. Okay, or for some of us it might be easier to think about this. I've got 4 different pieces of 20 plus 4 because I've got a 4 out here that I would multiply. So remember that multiply means how many times you're chunking these things together and then adding. So I could take 20 plus 20 plus 20 plus 20, and then 4 plus 4 plus 4 plus 4, and add them together, and I would still get my same answer. So the distributive property then at the end of all of this is kind of written like this. So I've got these two things that are being added together inside of my parentheses, and they represent one term, and outside I have the number of times that those things are happening. And so the distributive property tells me that whatever is on the outside being multiplied here, I can multiply times each piece on the inside. So notice that the B and the C, they're both represented on the inside. And that A is in both locations. It's multiplied by both pieces. So we're just going to go ahead and we're going to take a look at some examples here. And I'm just going to rewrite this using the distributive property. So again, I've got the 5 is the piece that's on the outside, and I know, based on my definition, that it's going to go in both places. And then I've got the X, which is the first piece on the inside, and I've got the 7, which is the second piece. And now all I need to do is simplify. So 5 times X is going to remain 5X, plus 5 times 7 is 35. And so I have done the distributive property, and I have simplified this piece from something that looked kind of long and weird to just 2 terms, 5x plus 35. Okay, we'll look at one more example here, and then I'll have you try some on your own. So I've got -6 times w minus 3. So again, I've got -6, and I've got another -6 over here. And I'm going to then put the pieces that are inside of my term. So I've got a w here, and I've got a -3. Notice that I included this whole entire piece as a -3. So now I have -6 times w is just -6w, and I've got -6 times -3. Negative times a negative gives me a positive. And I've got -6w plus 18. Okay, so this one is written just a little bit different, but I've got my number on the outside over here. It's last. It doesn't make any difference. It's still the piece that is not being added or subtracted inside of the other parentheses. So I still have my lone piece right over here. So go ahead and hit pause. See if you can do this one using the distributive property, and when you're ready to check your answer, go ahead and let me know. Okay, so I've got -3, and I've got my other -3, my piece that's on the outside. Inside, I've got over here 4, and I've got f that I am multiplying by also. So negative 3 times 4 is negative 12. And then I've got negative 3 times f is just negative 3f. And I have simplified. So now we might be solving some equations using the distributive property. So I can't really solve this equation the way it is set up until I do the distributive property. So here's what I'm going to do. I'm going to take this chunk right here and I'm going to do the distributive property with it. So I've got the 4 and I've got my other 4, and now I'm going to go ahead and insert my other terms. So what I'm left with here is 4x plus 12. Now notice that I haven't touched this guy over here, so the rest of my equation has not changed one bit. I've got 4x plus 12 now equals 20, and this is a two-step equation that we should be used to solving, so I'm getting x by itself here, so I need to move the 12. And so whatever I do to one side of my equation, I have to do to the other. And remember, I subtracted 12 so that that piece right there would become 0. So the 4x is left, and 20 minus 12 gives me 8. And so now I'm looking at what number could I multiply or divide by that would cancel that 4 out and leave me with just an x. And so 4 divided by 4 is 1. Those cancel. And I'm left with 2. Okay, so I did the distributive property first right here. Okay, simplified that, and then I just solved like normal. So go ahead and give this example a try on your own, and when you're ready to see the answer, go ahead and hit play. Okay, so I'm taking, first of all, and I'm going to do the distributive property again. I've got negative 2 is my outside term, and so I know that it's written twice. My inside pieces are each going to be multiplied by that negative 2, and the rest of my equation is remaining the same. So now I have negative 2m. Negative 2 times negative 5 is plus 10 equals negative 18. My next step to get m by itself is to subtract 10 because I have to do the opposite of adding 10 to make those things become 0 so that they are no longer in my problem. Negative 18 minus 10 more is going to get me more negatives, and so I have negative 28. I now can divide by negative 2, and m is going to equal a negative divided by a negative is positive 14. Okay, that looks like all we got for the distributive property. We're going to go ahead and practice that.